Hey there, Sam! Authentication is something super important in a typical web app, but it is also something that we all dreaded to write. Luckily for us, Laravel has an official package called Fortify that takes care of everything about authentication for us, so we don't need to start from scratch. Alright, let's install it. We'll go to the documentation and copy the installation instruction. We'll install it using Composer. Then we'll publish the config file. And finally, run a migration to create the relevant tables. Once we do that, we should go to our apt config file and load the Fortify Service Provider class into the providers array. The Fortify Service Provider will register all the relevant Fortify actions for us, as you can see here inside the boot method. We've got create user, update password, and reset password, and each of these actions are customizable. And these action classes are living inside the action folder in our app directory, which was created by Fortify when we published the configuration of the package. These action classes will contain a logic to tell Fortify what to do on the corresponding authentication operations. Other than binding the authentication logic, the Fortify service provider has also defined two rate limiters for us. The login rate limiter, where it will block the user after 5 failed attempts in a minute. You are free to customize the duration of the limiter. For example, if you are building a financial app, then it might make sense to improve the security by making the interval an hour instead of a minute. The other rate limiter is for the two-factor authentication feature provided by Fortify. Based on the definition here, the user cannot submit more than 5 two-factor verification per minute. Okay, now let's go into the Fortify config file and explore the configurations that are available to us. So firstly, we see a guard option here. In summary, guards define how users are authenticated for each request. By default, Fortify is using the web guard, and we can find its configuration inside the auth config file. The web guard is using the session driver, which basically means that we are storing the authenticated user inside the session storage. And every time there's an incoming request, we'll simply verify if the user exists inside the session storage or not. If yes, that means the user is already logged in. If we use a token driver instead, then the user will be authenticated solely based on API token containing inside the request. The provider option indicates a way for Laravel to retrieve the user information. And the relevant option is defined further down in this file. And as you can see here, the user's provider is using Eloquent, and the matching model is a class name that refers to our user model. For most of the time, you don't really need to touch this option as they will just work out of the box. But if you really want to learn how to create our own customized guard and the details on how authentication works behind the scene in Laravel, we will explore more about this in another video. Otherwise, there'll simply be too much to cover. Anyway, let's go back to our Fortify config file. So the web guard simply means that we want Fortify to authenticate the user using the session storage and also Eloquent. For the next configuration, we have passwords, which is again a config to tell Fortify the password reset settings, and the corresponding configuration value will be inside our auth config file under the passwords key. Again, for most of the time, you don't need to touch these settings. The next config is username and email. Username needs to match with one of the model fields in our user model, and email refers to a field in the incoming forgot password and reset password request, where we need this field to send a user a reset password link. Home is the home URL of our app, and it is a location where Fortify will redirect a user to when the user has successfully logged in. Since we're building an API server, this value is not that relevant to us. Prefix is a great way to add a prefix to all the Fortify routes that will be registered. And domain is a way for us to add a subdomain in case we want to delegate of our authentication route to a different domain. And just for demonstration, we can list all of our routes now by using PHP Artisan route list. And as you can see in the list, hopefully it is not too small for you. These are all the API routes that are provided by Fortify out of the box. Now if I add a prefix, something like API, rerun PHP Artisan route list again, and as you can see, all the Fortify API routes have now got an API prefix in front of them. The middleware option allows us to easily attach middleware to all of the Fortify routes, and the limiter option allows us to customize the limiter applied to the login and two-factor authentication routes, which by default is using the login and two-factor rate limiter as we define in the service provider. The views option will tell Fortify if we want to include the routes that returns the view for each authentication operation. Since we're building an API server and we don't need a front end, I'll set it to false. The next section is the feature of Fortify that we want to enable in our app. So we have registration here, which will allow people to sign up as a user in our app. Reset password will enable users to reset their passwords. Email verification would force user to verify their email before they can sign up or use our app. Update profile information and update password will allow users to update their profile and change their password. Two-factor authentication will enable the user to set up two-factor authentication, and the confirm password option here, if we set it to true, that means the user will need to enter their password during two-factor authentication, whether it is enabling or disabling two-factor authentication or getting or renewing the recovery codes for two-factor authentication. Enabling each of these features will tell Fortify to include the corresponding routes. For example, at the moment, we have the two-factor authentication routes inside our route list. If I comment out the two-factor authentication features, go back to our terminal and run route list again, we can no longer see those routes in the routes list. And that's a quick introduction to Laravel Fortify. I think it's a good place to stop here. In the next video, we'll discuss more about the features in Laravel Fortify, and I'll go through each one of them with you. Key takeaway for this lesson: Laravel Fortify is a package that takes care of most authentication logic for us. Fortify provides us several authentication features out of the box, namely registration, login, reset password, email verification, update profile information, update password, and two-factor authentication, so that we don't need to implement these common features from scratch. That's it for now, and I'll see you again in the next lesson. Hey there, Sam! In the previous lesson, we talked about the features in Laravel Fortify. Let's take a deeper look at them in this lesson. First thing first, let's comment out all the features in Fortify, and we'll investigate how Fortify will behave at its core level. Let's go to our terminal and run PHP Artisan route list. And as you can see here, at the bare minimum, Fortify will only add a login, logout, confirm password, and confirm password status routes to our app. Let's test each one of these authentication routes out. Let's start with the login route. We'll need some dummy data, so I'll seed our database by running the PHP Artisan dbseed command. Now at this point, we can't use Postman or any other external HTTP client to test these endpoints. The reason is because our API endpoints here in Laravel are protected by the Verify CSRF token middleware. Since we are applying the web middleware group in our Fortify config, and the web middleware group contains the Verify CSRF token protection, the CSRF or CSRF attack is a type of attack where a hacker would use to perform operation on a web app on behalf of the user without the user knowing it. A standard way to avoid the CSRF attack is to attach something called the CSRF token inside every API request. Only the legitimate request will contain a CSRF token. So if an incoming request does not contain a valid CSRF token, Laravel will block the request immediately. Let me illustrate this for you to better understand the CSRF attack. Let's say this is Joe, our average daily internet user. Now today, Joe logged into his favorite banking website to make some payment to his friends. The bank web app uses a session storage to store all the login sessions. Once the bank has stored Joe's login session, it now sends back a response to Joe along with a session cookie, which Joe's computer browser will keep as a proof that Joe has already logged into the bank. Any subsequent API request that Joe sends to the bank will contain this cookie, and the bank will use this cookie to identify Joe's session inside the session storage. Everything seems to be fine until suddenly HackerBan has joined the chat. You see, HackerBan has targeted Joe for quite some time now, and he knows exactly that Joe will do some internet banking at this time of the day. So HackerBan has previously prepared a malicious website that contains some nasty JavaScript code that will send API requests to the bank website that will transfer money from the victim's account to HackerBand's account. And on the surface, this website seems like a harmless website that has nothing to do with banking. Once everything is prepared, HackerBand then sends an email to Joe with the email title of "You have just won $1 million worth of Bitcoin," while prompting Joe to click on the link inside the email body that will redirect Joe to the malicious website that HackerBand has previously prepared. This happened while Joe still has an active session in his banking website. Immediately after seeing HackerBand's email, Joe jumped out of joy. He thought that he's the luckiest person on earth, and he can't wait to click on the link. Upon clicking on the link, Joe encountered a dodge staring at him in his eyes on the screen. Disappointed, Joe thought to himself, "There is no Bitcoin after all." But at this point in time, it is already too late for Joe, because HackerBand's JavaScript payload is already executing while Joe is staring at the Doge and thinking about investing in Dogecoin. So HackerBand's JavaScript payload proceeds to run in Joe's browser and sends the transfer money API on behalf of Joe. And since Joe is currently logged into the bank assumes that the API requests are authorized by Joe and went ahead and transferred all the money to HackerBand. This all happened within a few seconds and without Joe knowing it. And that is a simplified example of how a C-serve attack would look like. And now the question is, how can we prevent this? And one of the solutions is to introduce the C-serve token. So the idea is that a bank web app would issue a unique token known as a CSRF token to all of its website visitors. Whenever the website visitors sends an API request, it should also attach the CSRF token issued by the bank web app. So now all the requests that Joe sent to the bank will contain the cookie and also the CSRF token. And upon receiving a request, the bank web app would verify the CSRF token by comparing it against the CSRF token that it issued before. By introducing the CSRF token, HackerBand can no longer perform the CSRF attack. The reason is because there's no way HackerBand can get the CSRF token issued by the bank web app, because the CSRF token only exists inside the page that Joe has visited, and HackerBand is sending the API request from its malicious page, and he couldn't see the CSRF token issued to Joe, so he can't attach the CSRF token into his malicious request, and therefore all the money transfer API requests will fail. So the moral of the story is, don't be like Joe and click on any random link in the internet, and always use a private window or the incognito mode in your browser when you're banking. And now back to our code. We now know that in order to send a request, we need to attach a CSRF token issued by Laravel inside our request. And that means we can't use HTTP client like Postman, because we won't have access to the CSRF token issued by Laravel. I'll show you what I mean. So now if we go to Postman and send a post request to the login route, we see an error in the response saying that CSRF token mismatch. So the question is, how can we solve this? We'll need to install another package called Laravel Sanctum to address this, for which we'll talk about in more details in the next few videos. For now, just to keep this lesson going, I'll disable the CSRF token verification so that we can test the Fortify routes. We will revisit this topic again in the next few videos, and I'll show you the proper way of implementing CSRF token verification in the context of API server using Laravel Sanctum. Alright, now let's go back to Postman and we'll send our login request again, and now this time it works, returning us with a 200 response code. Alright, now we'll test the confirm password route. This route will only work if the user is currently logged in. It is a post request and the body should contain a password field. This route is very useful in situations where we want to reconfirm the user's identity. For example, when the user wants to change their profile information. Let's click on the send button, and our app returns a success response with an empty body. Now if the password is not valid, Fortify will return us an error response. Okay, next we have a GET request to confirm the password status of the user. Let's go back to Postman, change the request, and we see a success response. Great, let's move on. Next, we'll try to log the user out using the logout endpoint. And we'll see a 204 response with an empty response body. And now since we are logged out, if we try to call an endpoint that requires the user to log in, we'll see an error. For example, if I send a GET request to the confirm password status endpoint, we'll see a 401 status code with the response of unauthenticated. Alright, we just went through the basic features of Fortify, and now let's investigate the registration feature. We'll go back to the config file and uncomment the registration feature. And we'll go back to our terminal and run php artisan route list again. And this time we see a new addition to our route list, which is the register endpoint. Let's go back to Postman and test it out. We'll send a post request to the register endpoint, and in the request body, the register endpoint accepts 4 fields: name, email, password, and password confirmation. Once we're done, let's click on the send button, and we get a status code of 201 with an empty response body. At this point, we should have created a new user. Let's check it. We'll send a GET request to our user's index endpoint, and scroll all the way to the very bottom, and we see hacker ban, and that means our endpoint is working. We can customize the registration logic by modifying the create new user action file, living inside the actions Fortify directory. So if your front-end form contains other fields than the basic email and password, this is a place where you can customize the logic to create a new user. Alright, let's move on. Next, we'll enable the reset passwords feature, and it will add the forgot password and reset password routes to our app. The forgot password route will send an email to the user with the password reset link in the body of the email, and the reset password endpoint will actually reset the user's password. Let's go to Postman and try out these two routes. We'll reset the password for HackerBan. It will send a post request to forgot password, and the body should contain an email field, which is the email address of HackerBan. Now currently we're logged in. If we attempt to send this post request now, Laravel will throw us an error, because we're not supposed to forget our password while we're still logged in. So we should log out first, and then we'll try to forget our password again. And now we see a new error, saying that the route password reset is not defined. So it turns out that the link inside the password reset email should redirect the user to a view where the user can reset their password, since we have told Fortify to disable all the views in our app, and hence the password reset route was not registered by Fortify. So to work around this, we should define our own password reset route, where it will show a form for the user to reset their password. I'll copy the route definition from Fortify's source code, which is living inside the routes.php file inside the routes folder. And I'll paste this route definition inside our web.php. And I'll refactor the code so that it will simply return us the password reset token. Let's give this another try. We'll go back to Postman, click on the send button again, and we get a 200 response, telling us that Laravel has sent us the password reset link. I'm using Mailtrap.io to capture any outgoing email, and inside my Mailtrap.io dashboard, we do see a new email coming into our inbox, and it is sent from our app that contains the password reset link. Let's click on it, and we're redirected to our password reset page, which is returning us our password reset token at the moment, as defined in our route just now. And now let's try to reset our password. We'll copy the token and go back to Postman, send a post request to reset password. These endpoints accepts 4 fields inside the body: the user's email, the new password, and the new password confirmation, and lastly, the password reset token. Let's click on the send button, and we see a success response. Great! Our endpoint is working, and now we should really consider to make a proper view for this endpoint. Let's go ahead and do that. I'll create a new folder called auth in our views folder, and I'll create a new blade file called password reset in it. And now I'll use my fast forward life hack to quickly create a form to reset the user's password. My life has been very productive since I learned this skill. I highly encourage you to learn that skill as well. Once we're done, we'll go back to our browser and hit refresh, and our form is showing on the screen. Great! I think it is a good place to stop here. We'll continue in the next lesson. Key takeaways for this lesson: Laravel protects all its web routes from CSRF attacks by default. We will need Laravel Sanctum if we want to protect our API routes from CSRF attacks. We can use Fortify action classes to customize the user registration logic along with other actions. The password reset post endpoint requires a GET route with a name of password reset in order for it to work properly. Otherwise, Fortify can't generate the email for the user to reset a password. That's it for now, and I'll see you again in the next lesson. Hey there, Sam! Let's continue from where we left off in the previous video. We discussed about the registration and reset password features in Fortify, and now let's move on to email verification. In summary, the email verification feature, as the name suggests, will force the user to verify their email when they sign up to our app. Let's enable the feature in our config file, and we'll head to our terminal and run php artisan route list. And here, as you can see, the feature has added 2 new routes to our list. The post-email verification notification endpoint will send an email verification link to the current logged-in user. This typically happens right after the user has just signed up to our app. And if the user clicks on the link inside the email, which is the verification get route here, their email address will get verified and they can continue to use our app. Now, before we go through the whole verification process, if we want to force our user to verify their email, we need to get our user model to implement the must verify email contract. So let's go to our user model and implement the interface. And now the email verification feature should work. Now let's go to Postman and we'll test out the email verification routes. As I mentioned earlier, the post route for email verification will not work unless the user is logged in. At the moment, no one is logged in our app. So if I try to send a post request to the endpoint, it should fail. And as expected, we get an error. Okay, now let's try to go through the whole sign-up process again. First of all, I'll register a user by sending a post request to our register endpoint. And we get a 201 response. That means our user is created successfully. And since we have told our user model to implement the must verify contract, at this point, our app should have sent a verification email to our user. Let's go to mailtrap.io and we see an email in our inbox telling us to verify our email. Let's click on the link. Oops, we see an error saying that our login route is not defined, which makes sense because we have disabled all the views in Laravel Fortify. But why are we getting redirected to the login route anyway? And if we look at the stack trace, we notice that this error comes from the authenticate middleware, which means we're trying to send an API request to a protected route. This email verify endpoint is protected, and the fact that our app is trying to redirect us to the login page means that we're not logged in. We are logged in Postman, but not in the browser. The browser did not have the correct cookie when it is sending the GET request to verify our email, and our app could not possibly tell our user is logged in without any cookie. So to get this to work, we should send this GET request inside Postman, where we do have the authentication cookies. So I'll copy the URL and go back to Postman and send it as a GET request. And now we get a status code of 202 back and did not see the error anymore. At this point, Laravel would have already verified our user's email. And now if we try to view our data in MySQL, we will see our latest user will have a timestamp for the email verified at column. And that means our latest user has verified their email. Now if you want to protect our routes so that only verified user can access them, we can apply the verified middleware to our routes. The verified middleware is defined inside our kernel and in a routes middleware mapping, as you can see here. And just for demonstration, I'm going to apply this middleware to all of our API routes by putting it inside our API middleware group. And now let's go back to Postman. I'll log out the current user and log in as HackerBan because HackerBan has not verified his email yet. Oops, I entered the wrong password. Let's try again. And we're in. And now let's try to call one of our API requests. Since HackerBan has not verified his email yet, we would expect an error. We'll try to call the getUsers endpoint, and we see an error. Great, that's email verification in a nutshell. Now let's move on. The next Fortify feature will enable us to update the user's profile information. Let's go back to our terminal and see the newly added routes. So Fortify has added a new put request that will update the user's profile information. To customize the update logic, we can go to the Fortify action folder in the Update User Profile Information class and refactor the code as we see fit. By default, the API only accepts two fields, the name and the email fields. Let's go back to Postman, and we'll log in as a verified user and attempt to update the name of the user. We will send a put request to the user profile information endpoint, and in the body, we'll change the name of the user. Oops, the email is also a required field, so we'll put that inside the body as well. Let's try that again. And this time it works. By default, from the code that Laravel has given to us, if we attempt to change the user email, Laravel will send another email verification email to the user, and the user has to repeat the whole email verification process again if we have implemented the must verify email contract for our user model. Anyway, let's move on. The next feature will enable routes for the user to update their passwords. Again, let's go to our terminal and take a look at the routes. And we see a new put endpoint that is linked to the update method inside the password controller provided by Fortify. Again, we can tweak the update password logic inside Fortify action class, namely the update user password class. And as you can see here inside the logic, the endpoint expects two fields, the current password and a password field. Let's give it a shot and try to change our current user's password. We'll go back to Postman and send a put request to the update password endpoint. The body will contain a current password and a new password. Let's click on send, and we see an error saying that we also need a password confirmation field. The reason is because inside the validation rules, the password field has a confirm rule included with it. The confirm validation rules requires us to attach a confirmation field inside our request body. So let's go ahead and fix that. And now let's try that for one more time. And this time it works. We get a 200 response code. And just to make sure that our current user's password is updated correctly, I'll log out and log in again with the new password. And it works. The last feature that we will go through is the two-factor authentication. This is a bit more complicated than the rest, and we'll continue to talk more about it in the next video. Key takeaway for this lesson: Fortify provides us a handy email verification feature to confirm the user's email address. We can use the verify middleware to protect our app routes. So if an unverified user tries to call our API endpoints, our app will stop the user. However, in order for that to work, we'll need to implement the must verify email interface to our user model. That's it for now, and I'll see you again in the next video. Hey there, Sam! And now it's time to implement the two-factor authentication. Now, first thing that you'll notice is that this feature accepts an array of options in its argument. And currently, there's only one option in here where Laravel has set a confirm password option to true. In summary, if we set this option to true, Laravel will provide additional security by prompting the user to re-enter the password when they want to set up their two-factor authentication. For now, let's take a look at the routes that this feature has added to our app. We'll go to our terminal and run php artisan route list. And now, as you can see here, we have a delete two-factor authentication endpoint and a post two-factor authentication endpoint. The post endpoint is for the user to enable two-factor authentication, and the delete endpoint is for the user to disable two-factor authentication. We also have a get endpoint for the user to retrieve their two-factor QR code, where they can scan the QR code in their favorite authenticator app on their phone as part of the setup. Now we also got the post endpoint and get endpoint for the recovery codes. The post endpoint is for the user to regenerate the recovery codes, and the get endpoint is for the user to display their current recovery codes. And finally, we also have this post endpoint to the two-factor challenge route. This is the route where the user will send a two-factor authentication code on their phone to our app, and Laravel will verify the code behind the scene. Alright, let's bring everything back together and go through the whole two-factor authentication setup process and verification process. So after the user has logged in, if they want to set up two-factor authentication, they will send a post request to the two-factor authentication endpoint. And if we have set the confirm password option to true, our app should prompt the user to re-enter the password and send a post request to the user confirm password endpoint. Otherwise, the setup for two-factor authentication will fail. Once 2FA is enabled, our app should send a GET request to the QR code endpoint to retrieve a two-factor QR code from Laravel Fortify. And then the user can proceed to scan the QR code in their Authenticator app. Once the two-factor authentication is set up successfully, our app should send a GET request to retrieve the user's recovery codes. If the user is not happy with the current recovery codes, they can send another POST request to the recovery codes URL to regenerate a new set of recovery codes. And now at this point, the user should be good to go. So the next time when they want to log in, right after they have entered their credentials, they should also send a POST request to the two-factor challenge endpoint with the two-factor code from their Authenticator app. And if for some reason the user decided to disable two-factor authentication, they simply need to send a delete request to the two-factor authentication endpoint here. And that's basically the workflow of two-factor authentication in Laravel Fortify. And now let's dive into the code right away. First of all, let's talk about the confirm password option here. As I mentioned just now, if we set this to true, Laravel Fortify will force the user to confirm their password when they want to set up their account with two-factor authentication. But how does this thing work behind the scene? To answer this question, let's dive into the source code of Laravel Fortify. We will open the routes file, and this is where Laravel Fortify defines all of its endpoints. We'll go to the two-factor authentication section. And as you can see here, the code is very easy to read and understand. The first if statement here is simply checking if the two-factor authentication feature is enabled. And we will register the routes only if it is true. What we're interested in here is the two-factor middleware variable here. What it is doing is checking if the confirm password option is true or not. If yes, the middleware will contain the authentication guard and password confirm. Otherwise, it will just be the authentication guard. And then Laravel Fortify went ahead and applied this middleware to the rest of the routes registered down here. So the user has to confirm their password when they attempt to enable or disable two-factor authentication or get a two-factor QR code, and also getting and regenerating the recovery codes. And now here's another question. How does the password confirm middleware work? To answer this, we'll need to go back to our kernel class. And we see that the confirm password middleware is mapped to the require password class. And we'll go to the handle method of the require password middleware class. We can see that it is simply running a function called should confirm password to check if the user has confirmed the password or not. And inside the function, what it really is doing is getting a key in the request session called password confirm at, which is a timestamp when the user last confirmed their password. And we subtract it from the current time to determine whether if the user needs to reconfirm the password again by comparing against the password timeout property. And how would the user confirm the password? The answer lies inside the confirm password route. Let's go back to the Fortify routes file and we'll look inside the controller of the password confirm route. And as you can see in the logic, once the password is confirmed, Laravel simply set a new key called password confirm at inside the request session with the value of the current time. And this value in the session will be put forward for future use, for example, in the confirm password middleware. So hopefully that makes sense. You should now have a better understanding on how these methods and functions connected together. Alright, now let's go ahead and test the two-factor authentication workflow. First thing first, we'll go to our terminal and list down all the routes. And then we'll go to Postman and log into our app. Once we're logged in, the first thing we want to do is to enable two-factor authentication. And we can do that by sending a POST request to user/two-factor authentication. Whoops, we got an error because we have enabled the confirm password option. So we first need to confirm our password by sending a POST request to user confirm password. And I have also forgotten one more thing. In order to get two-factor authentication to work, we also need to go to our user model and get our user model to use the two-factor authenticable trait. And now let's go back to Postman. We will send a POST request to the confirm password endpoint. And the request body should accept the current user password. Let's click on the send button and it works. And now let's go back to enable our two-factor authentication. And this time we get a status code of 200, and that means we have successfully enabled two-factor authentication. Great! And now let's try to get a two-factor QR code. I'll send a GET request to this endpoint. And in the response body, we get an SVG element. And in the front end, we're supposed to take this SVG element and render it in our browser for the user to scan it in their Authenticator app. And unfortunately, Postman cannot render this SVG element. Alright, let's move on. Next, we'll try to get all the recovery codes by sending a GET request to the user two-factor recovery codes endpoint. And in the response body, we get an array of recovery codes that looks sort of like gibberish. And in the front end, we should prompt the user to keep these recovery codes in somewhere safe. Next, we'll try to regenerate a new set of recovery codes by sending a post request to the same URL. And we get a 200 response with an empty body. We should have get a new set of recovery codes by now. Let's send another GET request to retrieve our recovery codes again. And we get a new set of recovery codes. Great! And just one note here, any given user can only have one set of recovery codes at one time. So that means if we keep calling the GET request to fetch the recovery codes, we will always get the same result. Alright, let's move on. Next, we'll try out the two-factor challenge endpoint. In Postman, we'll send a post request to this endpoint, and this endpoint is expecting the request body to contain either the two-factor authentication code from our Authenticator app or one of our recovery codes. I did not use an Authenticator app in this demonstration, so I'll go ahead and use one of my recovery codes. Let's send a request. And we get an error saying that this route is not found. Now this happens because currently we're logged in. Laravel Fortify will not allow us to do the two-factor challenge while we're still logged in. So let's go ahead and call the logout endpoint. And now we should have successfully logged out. And now if we go ahead and call the challenge endpoint again, we see another error saying that our authentication code is invalid. Why is that? Because in order to do a challenge, first we'll need to try to log ourselves in. In a typical web app, the user will only do the two-factor authentication challenge right after they have successfully logged in. So here, we should really log ourselves in before doing the two-factor challenge. Let's send a post request to the login endpoint, and in the response body, we see a field called two-factor set to true. The front end can use this value to determine whether to prompt the user to enter the two-factor authentication code or not. And now we're logged in, but we haven't done the two-factor challenge. And if we try to call any endpoint in our app, we should get an error. And as expected, we got a 401 error saying that we're unauthenticated. Okay, now let's try to do the two-factor challenge. We'll send a post request to the two-factor challenge endpoint, and we see a 204 success code with an empty body. And that means we should be in by now. Let's send a GET request to try and fetch all of our recovery codes again. And we no longer see the unauthenticated message, but instead we see an error telling us to confirm our password again. And the reason is because we're now logged into a new session. And in this new session, we haven't confirmed our password yet. So let's go ahead and do that. And once we have confirmed our password, let's try to refetch the recovery codes again. And we get a success response. But one thing to note here is that we got ourselves a new set of recovery codes. This is intentional because for security reason, if the user used their recovery code to log in, that means the two-factor authenticator could be compromised. And Laravel Fortify will issue the user a new set of recovery codes just to start fresh. And in the front end, we should really show the user this new set of recovery codes and prompt them again to keep them safe. Alright, lastly, we'll test our final endpoint, which is to disable two-factor authentication. We will send a delete request to the user two-factor authentication endpoint, and we get a success response. And that's about it. That's a lot of information, but it is everything that you need to know to work with Laravel Fortify. Have a go by yourself, and just play around with this endpoint until you're comfortable with them. Key takeaway for this lesson: we need to use a two-factor authenticatable trait in our user model in order for two-factor authentication to work properly. The confirm password option will force the user to confirm their password when setting up 2FA. Laravel will issue the user a new set of recovery codes if they log in using their recovery code. That's it for now, and I'll see you again in the next video. Hey there, Sam. Laravel Fortify offers us quite a number of ways to customize the package, and that includes customizing the views or email that Laravel Fortify will send out to the user. Let's take a deeper look at that. To understand how email verification works, we first need to look at how Laravel Fortify sends out the verification email. To do that, we'll go to Fortify's routes file and look for the post endpoint that sends out the verification notification. We'll go inside the email verification notification controller, and in the logic, we can see that Laravel is calling the send email verification notification function on the logged in user model instance. And that means if we define this function in our user model, we can customize the logic of sending out an email verification notification. But how does Laravel handle this by default? Let's go to our user model. And as you can see, our user model looks quite empty by default. Laravel has hidden a lot of code by default within a framework. And now if we look at the must verify email contract, which is also known as interface, we can see that there's a function called send email verification notification in it. Since this is a PHP interface, that means this function is defined somewhere inside the framework. Let's do a global search, and we found it. It turns out that this function is included inside the must verify email trait, provided by Laravel inside the illuminate auth namespace. And the function logic here is quite simple. It simply calls the notify function from the user model and accepts a new verify email notification class instance. We haven't spoken about notification yet, but the idea of it is very similar to sending out an email in Laravel. However, with notification, we can get Laravel to send out to different channels like Slack, Discord, or SMS. These are the alternative ways for us to send notification to our user if we prefer not to use email. Anyway, let's go inside the verify email class, and we can see that there's quite a bit of things going on here. But the main part that I need you to look at is this toMail function. Out of the box, Laravel will use a mail channel to send out notification. And this toMail method is exactly what Laravel uses to build the email message to send out to the user. And the logic of it is quite simple. First of all, we'll create the verification URL, and then we'll pass in this verification URL into either a custom callback function or the built-in build mail message function. The fact that Laravel is checking and calling a custom callback function means that we can customize this verify email notification class without creating a brand new custom one from scratch. We'll go through the custom callback in just a minute. For now, let's look at how the build mail message function works. As we can see here in the function logic, it is simply returning a new instance of the mail message class. The mail message class is a helper class that allows us to quickly create a one-off email template without the need to create a separate view file. The API here is quite easy to understand. As you can see here, we just need to call the subject method to define the subject of the email, and the line and action method will allow us to define the body of the email. And we're calling the get method from the lang facade to fetch a translation of the provided key to a different language. This is part of the internationalization of Laravel. We will revisit this topic in more details in the upcoming videos. For now, you just need to think of the lang facade as a quick way to grab translation for a different language. Now, if we want to customize the mail building logic, we can either use the mail message helper class or provide our own view template. The verification email needs to have a verification URL contained in it, which is represented by the URL argument here. And by default, this URL is generated by the verification URL function. And again, if you look inside the function body, Laravel offers us a way to customize the URL generation logic. If we did not supply the custom callback, then Laravel will generate a URL by using the sign route method from the URL facade. The temporary sign route method will create a temporary link that has a signature or token attached to it. Having this unique signature can help us to protect a certain route so that we only allow a certain user to access the route. In our case here, we only want the current logged in user that is undergoing the verification process to click on this link. We are encoding the user's information into this route, which in our case here will be the user ID and the user's email. And we're hashing the user's email using the SHA-1 hashing algorithm. Since the user's information is encoded into the URL, if someone else attempted to click on this link, the encoded user information will not match the imposter's information, and therefore we'll know that this link is not clicked by the legitimate user. There's a lot more to talk about the sign route in Laravel. I think it deserves its own video, and I'll stop it here. Okay, for now, let's try to customize this verify email class. We're gonna set up the custom callbacks to build the mail notification and also the verification URL. we will write our customization logic inside the auth service provider. To customize the mail building logic, we will call the toMail using static method. The method accepts a callback function that accepts two arguments. The first argument is the user, and the second argument is the verification URL. And what we want to do here is to simply return a view. Let's go ahead and create a blade file inside our views folder. And I'll call it verify.blade.php. I'll be using Laravel's built-in mail markdown component by using the mail message directive. And I'll go ahead and type in something stupid here and pass in a verification link for the user to verify themselves. And now we'll go back to auth service provider. And inside the callback function, we need to return a new instance of mail message. Let's create a new mail class for our verification notification. We'll go to our terminal and type in PHP artisan make mail. And I'll call it verify mail. And now inside our mail folder, we can see our newly created verify mail class. Let's modify it so that it will send the verification email to the user. I'll get a mail class to accept our user and also the verification URL. I'll make these two properties public so that they'll be passed into our Blade template automatically. And now inside the build function, we will return a markdown, which is referring to our verify.blade.php. And we also need to specify who do we want to send this email to, which in our case here, will be sending to our user's email address. Alright, let's go back to our auth service provider, and we'll get our callback function to return a new instance of our mail class, and pass in our user and verification URL to the constructor. And now let's give our code a test. We'll go to Postman and register for a new user account. And we get a success response. At this point, the user should have received a new email telling them to verify their email address. And we head to mailtrap.io and we see a new email in our inbox and our custom verify mail message. Great! So that's how we can customize the verification email in Laravel. We can also customize the logic to create the verification URL by calling the create URL using method and passing a callback function in it, where we'll write the logic to create our own custom verification URL. For most apps, I do not encourage you to touch this logic at all. Just use what Laravel has already provided us. We'll stop here for now. In the next video, we'll explore more ways that we can customize Laravel Fortify. I'll see you there. Key takeaways for this lesson. Laravel Fortify relies on a built-in verify email class provided by Laravel to send out verification emails. We can call the verify email toMail using method to define our own logic to send out the verification notification. We can encode information into Laravel's sign route for the purpose of validation. This is very useful if we want to create routes that is only accessible by a certain user. That's it for now, and I'll see you again in the next video. Hey there, Sam! Laravel Fortify also allows us to customize the login logic. The first thing I want to show you is a way to modify the default login function provided by Laravel Fortify. To do that, we'll go to our Fortify service provider and we'll call the authenticate using static method from the Fortify class. Now this method allows us to override the default authentication logic provided by Fortify, and it accepts a callback function, and the callback function receives an instance of the request as its argument. Now we're free to write any logic that we want inside this function. In order to log a user in, we simply need to return the user instance, and that means look up the user from our database and return the user model instance inside this function. And again, for most cases, you don't have to customize the authentication logic, unless you're not happy with how Laravel does authentication out of the box. And now, just for demonstration, I'll not return any user instance in this function. Instead, I'll just return a false and expect all the login attempt to fail. And now we'll go to Postman and send a login request to our app with the credentials of a valid user that we have registered in the last video. Let's click on Send. And as suspected, it does not work. Now let's go back to our code, and this time I'll hardcode the authentication logic to return a known user. So it doesn't matter what the credentials that the request has sent us, we will always log in with the user with ID number 1. And now let's go back to Postman. I'll duplicate our login request. And this time I'll type in some gibberish credentials. Let's click on Send again. And we're in. And that's how we can customize the login logic in Laravel Fortify. Again, what I'm doing here is just for demonstration only. Hard coding to log a user in is super dangerous, so do not do this at home. Alright, let's move on. Sometimes we want to add a few extra steps before or after the user is authenticated. For example, if we detected that the user has logged in from a different device or from an unusual location, we might want to send an email to the user to warn about this unusual activity. Laravel Fortify offers us another static method called authenticate through to handle this situation. And similar to authenticate using, this function also takes in a callback function that accepts a request instance as its argument. Now, Laravel Fortify requires us to return an array of classes inside this callback function. Each of these classes should be invocable, and that means each of the classes should implement the invoke magic method, because Laravel will attempt to call each of these classes one by one from top to bottom. If you haven't heard about the invoke magic method in PHP, it simply means that making a class callable. And that means once we define this magic method, we can call a class just like a function. And this is the authentication pipeline provided by Laravel by default. You can customize it in any way you like, just make sure that every class that you put inside this array is invocable. I'll show you what I mean. I'll go ahead and create a dummy class inside our Fortify action folder. And I'll define the invoke method inside this class. Now Laravel Fortify will pass a request instance to all the classes inside the pipeline, so we'll get our invoke method to accept an instance of our request class as its first argument. And the second argument is a callback function for us to move on to the next class inside the pipeline, which is very similar to the next argument inside Laravel middleware. We will need to call this next callback function in order for the pipeline to progress, otherwise our code will just stop. And just for demonstration, I'll dump something stupid in here and refuse to call the next callback function for now. And we'll go back to our Fortify service provider and load our dummy class inside the pipeline. If everything goes smoothly, our authentication process should stop at our dummy class, because we did not call the next callback function. Let's try it out. We will log out and log in again with the correct credential this time. And in the response, we see our string dump without any other information. And now let's go back to our code and we'll go back to our dummy class. And this time we'll call the next callback function and pass in our request to the next class in the pipeline. And now just for demonstration, I'll put two dummy classes inside our pipeline so that we'll see two sets of hey ya inside our response. Let's go back to Postman and I'll try to log in again. And now, this time, we see two sets of hey ya. And again, one more time, if I go back to my dummy class and comment out the next function, go back to Postman, try to log in again, and we only see one hey ya. Okay, so the next function is mandatory to call in order for us to progress inside the pipeline. Which in our case here, our pipeline stopped on the first dummy class because we didn't call the next function in our dummy class and our pipeline is broken. Alright, next, we can also customize the confirm password logic by calling the confirm password using static method from Fortify. Again, this static method will accept a callback function that takes in a user argument and also the password input provided by the user. What we need to return inside this callback function is a boolean. We will return true if the password is confirmed correctly, otherwise false. The user argument is an instance of the current logged in user, and the password argument is what the user has provided inside the request. And it is entirely up to you on how you verify these two information. And again, in most cases, you don't have to override this confirm password logic. Just let Laravel Fortify to do the work for you. Alright, let's move on. We can also customize the views that Laravel Fortify is sending out by using the following methods. This is extremely useful when you have enabled the views option in Fortify's config. In each of these callback functions, you just need to return the view to the corresponding page. However, this is not that relevant to a single page application or an API server, so we don't need these in the app that we are currently building. But feel free to play around with it if you are interested. it should be quite straightforward as the function name tells you exactly which view is it customizing. Alright, it's a good time to stop here. I will see you again in the next video. Key takeaway for this lesson, we use the Fortify Authenticate using method to override the default login logic. The authenticate through method allows us to customize the authentication pipeline. So in case if we want to add additional action in between the authentication pipeline, we can do so using this method. The confirm password using method provides us a way to customize the password confirmation logic. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. As we discussed in a previous video, to create a fully working authentication system in Laravel for an API server, Fortify on its own is not enough, because API users typically authenticate themselves using tokens or cookies, and Laravel Fortify does not provide such features out of the box. However, the good news is Laravel does provide us 2 extra packages to compensate this, and they are called Laravel Passport and Laravel Sanctum. Passport is designed for big enterprise applications where there's a need for OAuth and other advanced features. Sanctum, on the other hand, is designed for applications that only needs a simple means of authentication. We will be using Laravel Sanctum, and maybe we'll discuss more about Laravel Passport in another series. Alright, first of all, I would like to talk about how Laravel Sanctum works. In summary, Sanctums provide us 2 ways to authenticate ourselves. The first way is to use API tokens. So as long as an incoming API request contains a valid API token, the request will be considered as authorized. Typically, the client will include the API token inside the request header, and Sanctum will inspect the request header for the API token to authorize the user. Now the second way is to use cookie. Similar to the token-based authentication, Laravel Sanctum will also inspect the incoming request for any authentication cookie that it issued to the user before. If the cookie is inside the header and it has yet to expire, then the request is considered as authenticated. When a client first made a request to the server, Laravel Sanctum will issue the cookie to the response. Any subsequent request that the same client sent to the server will have this cookie included in the header. If the client made a successful login request to the server will take note of the cookie inside the request and mark it as authenticated in the server-sided database. So now the client has logged in, and for any future request, as long as the client has submitted the same cookie inside the header, Laravel Sanctum will inspect the cookie and attempt to cross-check it against a record on the server side. If the server has a record of the same cookie, then the request is authorized. Since we're storing a state on the server side, which in our case here will be the cookie, this process is also known as stateful authorization. And now the big question is, which one should we choose? And I'm going to answer this question with the most hateful answer. It depends. You see, API token is very simple, but it is also very risky. The reason is because if your token is stolen by someone else, that person can simply use your API token and act on behalf of you. There's no way the server would know the API request was made by someone else, because the only means of identification is through the API token. As long as the incoming request contains the API token, the server will simply assume that the request was made by the rightful owner. So the only way to stop the hacker from keep using your API token is to simply revoke the token. On the other hand, the cookie method provides more protection compared to the API token method. Laravel Sanctum makes use of the WebGuard when it authorizes requests using the cookie method, and that means our app will be protected from CSRF attack and cross-site scripting attack. However, the cookie method is more complicated to set up and also stricter, and that means it is harder for the client to send API requests. It is a trade-off between simplicity and security. These 2 methods are very common in a lot of web apps, and it is really up to you on which one to pick in your next project. In this app, I'll be using the cookie method, and now let's dive into the code and get started with Laravel Sanctum. Alright, first thing first, let's go to our terminal and install Sanctum by typing in composer require laravel/sanctum. The next step is to publish Sanctum's configurations. I'll type in PHP Artisan vendor publish and look for Sanctum, which happens to be 12. And we also need to run PHP Artisan migrate for Sanctum to create a table to store API tokens. Next, we'll go to our HTTP kernel file and we'll uncomment the verified CSRF token middleware, which we previously omitted. Now we no longer need to exclude it because we have installed Sanctum and it should start working once we have set up Sanctum. And to let Sanctum protect our API routes with cookie-based authentication, we should also load the ensure front-end requests are stateful middleware in our API middleware group. Including this middleware will make Laravel to inspect the incoming requests for the CSRF token and also the authentication cookies. Next, we'll need to configure some of the environmental variables. We'll go to our .env file. The first thing that we want to change is the session driver. We want to change it from file to cookie. This will instruct Laravel to store our session details in the form of an encrypted cookie. Next, we'll need to add a new variable called session domain. This tells Laravel which domain is our app located at, so that Laravel can safely issue the cookie for the session. Now this value must match with the domain of your front end. Otherwise there'll be issue inside the browser. I'll talk more about this later in the video. Now if you have an actual domain name, you should put it right here. You can prefix a dot in front of your domain name to support any subdomains that you may have. This is very important, especially when we have our front end living in a subdomain of our main domain. In fact, due to security reason, our front-end client and our server should be living in the same top-level domain with the same port. If we don't do this, most browsers will refuse to save the cookie from the server response. Again, I'll show you how this thing works later. The last variable that we want to set is called Sanctum stateful domains. This variable determines which domains will maintain the stateful authentication using Laravel session cookies. So for every incoming request, Laravel will inspect this variable to check whether it should make a stateful cookie or not. And if your app has multiple subdomains, you can use a comma to separate your domains. And always include a port number if the domain is not using a standard port. Otherwise, Laravel Sanctum will not work. Alright, now we're done with the environmental variable. Let's go ahead to our API routes and protect our routes with the Sanctum auth middleware. By default, Laravel uses the API auth middleware to protect the routes. However, this will not provide the benefit that Sanctum offers to us. To get Sanctum to work, we simply need to apply the auth middleware and passing in the Sanctum argument to it. Simple as that. Alright, our initial setup is now done. Let's give this bad boy a quick test. I'll quickly create a dummy web page and do our test in there. First, I'll create a new blade file, load the boilerplate, and go to our web routes and add the routes to it. Alright, back in our dummy web page, let's write some JavaScript to test Laravel Sanctum. Here's what we should do when we want to authenticate ourselves in the context of a single page application. Laravel Sanctum will protect its routes from CSRF attack. So the first thing that we want to do is to get a CSRF token from Laravel. And Sanctum will provide us this token in the form of a cookie. And to get this cookie, we need to send a GET request to this endpoint called sanctum/CSRF cookie. And I'll pass in the standard headers and also the credentials include option. We should have this option in all of our API requests. Otherwise, the browser will not send a cookie to our server. Alright, now let's open this page in our browser and we'll go to our network tab and inspect the CSRF cookie request. In the response header, as you can see here, our Laravel server is sending back us multiple set cookies headers, and this is exactly where our journey of stateful authentication starts. The XSRF token here is really our CSRF token. And live post session is our session cookie, where Laravel will use this to track our current browsing session. And the third one down here is some voodoo magic. I have no idea what that is. Might need to do a bit more digging into the source code to find out more. If you know what this cookie is, please let me know down in the comments below. My best guess is that it is some form of encrypted data, and it is there for security reason. And now, if we go to the application tab, under the cookies section, we can see that all the 3 cookies has been set inside our browser. And that means our browser is able to take in these cookies without any issue. Now let me demonstrate what will happen if we did not set up Sanctum correctly. Let's go back to our .env file. And I'll change session domain to localhost. Now remember what I said earlier, the browser will need the domain of the web page to be the same as the domain listed inside a cookie. And if we go back to our browser now, I would expect our browser will refuse to set this cookie. Let me clear all the cookies. And I'll refresh my page. And now we see a little warning icon besides our cookie. Oh dear. The other thing I need you to take attention of is that the domain key in our cookie is now set to localhost. which is exactly the value that we set for our session domain environmental variable. Let's hover on a warning sign. I think this is a bit too small for you to see it, but it says that the browser cannot set a cookie because the domain inside the cookie and the API host are different. To resolve this, we can either change the session domain environmental variable or simply change our URL to localhost instead of the IP address. So if I change my URL to localhost, the cookies are now setting again. Great. Now let's move on to the second issue. For the other environmental variable, we need to make sure that the domain that we listed here have the same top-level domain and also the port. If we don't include the port number or if the domain is not matching, then Sanctum will not bake stateful cookies for our app. And since we're using localhost now, I'll add localhost to our stateful domain list. I will show you now how we can log our user in from our front-end JavaScript. Let's go back to our dummy web page. I'll create a new function called login and send a post request to our login endpoint with one of the dummy user credentials. And I'll call this function right after we have received the CSRF cookie, and it should just work, right? Well, let's go to the browser and test it out. And it doesn't work. Oh dear, we've got a 419 error. It says that CSRF token mismatch. Well, here's the issue. Although this request has included the CSRF token in the request header under the field cookie, it will still not work in Laravel. The reason is because Laravel Sanctum expects us to put a CSRF token in a different field called XXSRF token in the request header. We did not do that and Laravel is not happy. Let me show you how we can achieve this. First of all, in our login method, we need to get the CSRF token from the cookie. Once we got that, we'll add the XXSRF token field inside the request header, and our job should be completed. And now the big question is, how do we get a cookie? The answer is simple. Just copy it from the internet. Here's a code snippet that I shamelessly copied from Stack Overflow, and it works great. It basically grabs all the cookies inside our browser and split the cookie string by the name of our target cookie. Each cookie key and value pair is separated by a semicolon. We call the port method on a parts array to get the last element, which is the remaining of the cookie strings, and we split it up again using the semicolon to break out the remaining cookies. Then we call the shift method to get the first element of the splitted array, which is our target cookie value. Let's try this out. We'll call the getCookie function and console log out our CSRF token. Let's go to our browser, hit refresh, and it works. However, you'll notice that the cookie string is encoded. The %3d at the very end of the string is actually a special character. In order to send our CSRF token back to Laravel, we first need to convert this special character back to its original form. And it's actually quite simple to do that in JavaScript. We simply need to call the decode URI component function, and the magic will just happen. Let's go back to our browser and refresh. And the %3d is now converted back to equal sign. Great! And now let's put our CSRF token into our request. I'll add a new field in our headers, and the value is the decoded CSRF token. Let's give this a go. And now our login API request is working. Great! We've got a login function. We should also implement a logout function. And now every time we want to perform an API request, we always need to include the headers, the CSRF token, and also the credentials option in the fetch function, which will be quite tedious after a while. Let's extract all of this into a generic request function where we can reuse it to easily call an API request. I'll create a new function called request, which is basically a wrapper around our fetch function with built-in headers and the credentials option. Let's refactor our login function to use our newly created request function. And also create our logout function, which is just sending a post request to the logout endpoint. And now before we test our code, we should really log out first before we log in again. So I'll call the logout function first in a promise chain before we call the login function. Once we're done, let's go back to the browser and refresh the page. And there's no error. That means our code is working. Beautiful. Now to test if our authentication is working, we'll try to call one of the API endpoints protected by Laravel Sanctum's auth middleware. Let's call the user's endpoint after we have logged in and go back to our browser And we can see our user's data is returning successfully and it's all working. Okay, now back to our main question. What will happen if I did not include my front-end domain inside the stateful domain list? Let's remove the port number from localhost and back to our browser, hit refresh. And now we see a 401 error on our user endpoint. And this is exactly what will happen if we did not include our front-end domain in a stateful domain list. Laravel will not authenticate the request because the request did not come from an authorized domain. Alright, let's go back to our .env file and put a port number back to our localhost. There's one last thing that I want to talk about before we end the lesson. If your front end is living in a different subdomain than your backend, you might encounter CORS error. And Laravel makes it very easy to fix this. We just need to head to our CORS config file and change the paths array, depending on which URL that you want to enable CORS. Also, one important thing to note here is that we always want to set the support credentials option to true. Alright, that's pretty much everything you need to know on how to set up and use Laravel Sanctum in the backend and also the front end. If you need more information, feel free to visit the documentation. The link is in the description. Alright, key takeaway for this lesson. Sanctum offers cookie-based authentication and token-based authentication. Token-based authentication is simple to set up and use, but it can be dangerous when a token is stolen. Cookie-based authentication is harder to set up, but it will protect our app from CSRF and XSS attacks. Cookie-based authentication is sensitive to domain names, so be sure to configure Sanctum before use. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam! Now that we have installed Laravel Sanctum and all of our API routes are now protected, we now encountered a new issue. So if we try to run our tests again, a lot of them are returning us an error. The reason is because when we write our API test, we did not log in as a user to call the API endpoints. Now that we have applied the Sanctum auth middleware to all of our API routes, it is normal for our test to fail. So to fix this error, we should refactor our test code to log in as a user before calling these API endpoints. Let's do that. Let's first refactor our user API test. Now to log in as a user in our test, Laravel offers us a very simple to use method called acting as, which will receive a user model record as its argument, and that user can be any valid user in our app. I'll go ahead and create a dummy user using the factory method and pass the dummy user into the acting as method, and that should do the trick. Let's try our code. We'll go back to our terminal, and you notice that currently we have 15 failures. Let's run our test again. And boom, we've got 14 failures now. And these two lines of code is exactly what we need to apply to all of our API tests. And now the question is, should we really copy and paste this to all of the test functions? The answer is a big no-no, because we'll need to repeat ourselves for an awful lot of time. There is a better way to do this, and it is through the setup and teardown testing hooks. So Laravel provides us two special testing methods called setup and teardown. Setup is a special function that will run just before each of the test function is executed. And teardown, on the other hand, will run after each of the test function is executed. So in our case here, we want to log the user in before each of the test function is executed. So let's go ahead and create the setup function. And we do need to specify the return type, otherwise our IDE will complain. Inside the function body, I'll simply move our login logic from the test index method to here. And now this setup method should log a user in before we run all the test functions inside this user API test class. Let's go to our terminal and we'll run our test again. And we're down to 10 failures. Beautiful. Now the next thing that we want to do is to copy and paste this code to the other test classes as well. We'll paste it in our post API test and also comment API test. Let's go back to our terminal, run our test again, and we're down to one error. Seems like this error is not about authentication, but we have an invalid request body when we're creating a new post. Let's quickly fix that. Our post body should be an array, not a string. So we'll go to our post controller and change the data type from string to array. We also need to include an array of user IDs. So I'll go back to our test method and quickly create a dummy user. And I'll pass the user ID as part of the request body. Since body is a required field, we will also go to our post factory and put in some random value inside the body field. Let's go back to our terminal and run our test again. And it's now all green. Great! Now before we end the lesson, I want to show you how teardown looks like. As I mentioned just now, teardown will run after a test is executed. It is useful when we want to reset any side effects that we might have when we are running our test. For example, clearing out database records or deleting files that we might have created in the test. And just for demonstration, I'll dump a random string in our teardown method here. Let's go back to our terminal and run our test. And we see 5 hey yes inside our terminal, because we have 5 test functions in our user API test class, and Laravel runs teardowns for 5 times. Now before we end the lesson, there's one more thing about the acting as method. It can actually take in a second argument where we can specify which login guard that we want to use. By default, it is using the web guard, but we can change it to API guard or other guards that you define inside the auth config file. And just for recap, guards are ways that we can log our user into our app. You can define as many guards as you like inside the auth config file. But for most scenarios, the default works great as it is already, so you don't need to touch them at all. And that is pretty much it. Key takeaway for this lesson: Laravel provides us a convenient acting as method to log in as any given user. The setup method is a handy special function that runs before every test function. It's good for us to put in logic where we want to apply it for every test function inside a test case. Teardown is the opposite of setup, and it runs after every test function. Acting as accepts a second argument where we can specify which auth guard that we want to use. We can add more auth guard in the auth configuration file if we wish to. That's it for this lesson, and I'll see you again in the next video. If you enjoyed the content of this video, don't forget to hit the like, subscribe, and the bell icon for more content to come. It will really help me out. Thanks for the support.